Okay, look up here for a bit, okay? Where is my die? Somebody, did I misplace it? Maybe somebody wanted to play games. Anyways, I don't have it right now, but um, can you just look up? Let's just look at the coin here. If I flip this coin and it landed on heads, does this result affect my next toss? Will it affect it in any way? So it's always one out of two chances, right? Every time. If I had a die, it would be the same thing, right? Every time I roll, whatever it lands on, it wouldn't affect, right? The next event wouldn't be affected, correct? However, if I have a deck of cards, I should be able to, deck of cards, right? If someone pulls a card, looks at it, keeps it, are the chances, the probability of someone else drawing a card, like this is not being replaced, this is staying there, is the next probability going to be different? Will it be affected? Yes. That's what we're going to be talking about, right? When you're not replacing what you've taken out, it's what we call dependent event. This depends, right? This event will affect the next one, so they're dependent. Versus just tossing a coin, right? That is not gonna affect, like, because you can't remove a possible outcome, right? You can't remove it from a coin. You cannot remove it from a die. You cannot remove anything, but from a card, deck of cards, you can. Marbles in a bag, candies in a bag, all of those things, you can remove it and eat it. You can eat the chocolate, don't put it back. It affects the probability of the next person winning. Yeah, basically. Yeah, dependent. Yeah, you remember that from grade 9 or maybe even grade 11. I don't know when. Okay, got it. So you all, I'm sure you're familiar with like the McDonald's Monopoly or like Tim Hortons. Do the chances of winning stay the same throughout the whole promotion or does it change? As people start winning, there are fewer RAV4s out there, right? Whatever they're offering, I don't know, RAV4, maybe it's not a RAV4 anymore. Maybe it's a Prius or something. But every time somebody wins, there's a less chances of you that gets affecting your odds of winning, your probability of winning. So let that sink into your brain as I'm doing these questions here. Okay, so let's go to 49. I'm going to pause this for a bit here because I need to have some highlighters ready too. Dependent versus independent events on page 49. And this is new. Right? This part right here is new. Everything that we've done so far has been independent, where the previous event, if there was an event that happened before, it didn't affect the second one. Okay. Independent events. There are events where the first does not affect the second. Right? First does not affect the second. The total possible outcomes remains the same. Okay. So example, if you draw a card, record the result, and replace the card before drawing another, right, the total cards remain unchanged. Rolling dice does not affect the total number of outcomes of the second roll, even the third, fourth, and so forth. You record results and roll again. But here's a different one, so I'm going to use a different highlighter for this one maybe. Dependent events. When the first event affects the total number of outcomes for the second event. The key word you want to look for is no replacement. It's keywords maybe, but no replacement. If there is no replacement of that object you drew, hint, hint, it's dependent events. something is going to change. When cards, marbles, candies, etc. are not returned after being drawn, it affects the total number of outcomes for the second draw. Example, your teacher picks random students to come to the front of the class, right? The chances of you being picked next actually increase since the number of students remaining is decreasing, right? The more I pick, the higher the chances that you'll be picked next because the total is decreasing. So at first, the chances of me picking Andre at the very beginning, it's 1 out of 10, right? So let's say I pick somebody's coming front, he wasn't picked. I picked somebody else, right? Then the next time I pick, it's 1 out of 9 chances of me picking Andre, right? So as time goes by, it increases, okay? A bag of marbles has, let's do an example, has 3 red, 5 blue, and 2 green marbles. Watch this. If a blue marble is chosen and not replaced, dun, 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 right? Should be a sound every time I say that. What is the probability of drawing a red marble next? So basically, a blue marble was chosen, not replaced. Let's go to our bag here and get rid of a blue here. This has been removed. You removed a blue. Okay. So probability of blue now will be, I actually want to depict this. I want to say we used to have, how many marbles did we have there? 10 total. Let's go 10 total. We used to have 10. And how many blues? Sorry. And we removed one. We removed, this is the blue marble. Okay. How many reds are left? Because the favorable, sorry, what did I say probability of blue, guys? I'm too excited to make my point here, and then sometimes I blow it. Sorry, guys. A blue one has been chosen, not replaced. It says, what's the probability of drawing a red marble next? So we got to go red, okay? So our total used to be 10. We took out a blue marble, it's gone, right? So we'll have 9 left. How many red ones are there in the bag still? 3. In fact, it hasn't really been affected by the blue that has been removed. The 3 reds stay. So this would be 3 out of 9. Okay. So I will also say, let's reduce this one. It's not too bad, right? Divided by 3, that's 1 over 3, which would be 0.3333, which is 33.33%. So total has been affected. Let's make a big total affected. So it should be the orange here. I might just do it like that. That's the orange one. It stands for that one that we removed. There we go. But I'm going to put various twists to it. If a blue marble is chosen, not replaced, dun, 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 right? State the probability of drawing, what does it say? Another blue marble. Okay, so how's this going to be different? Probability of blue. I want to say it this way, okay? How many blues did we have at the very beginning? We had 5. And we used to have 10 marbles in total. So if we remove the blue one, the first blue one, it definitely affects my total. You go from 10 to 9. But in this case, it will also affect the number of blue marbles that are left. because remember, we got to go to our bag, cross off one of these ones, and we're left with 4. Okay, and I will make an arrow again. Removed. So here, it's way too long of a line, right? I don't need that much. There. So this ends up being 4 out of 9, which turns out to be 0.4444, which turns out to be 44.44%. Okay. So in this case, both the numerator and the denominator has been affected because the first event not only changed the total, also changed the total number of blue ones that remain. So that'd be 4 out of 9. Okay. By the way, you could keep going, right? Another one has been drawn, another one has been drawn, but we're just going to stop there for now. Next, if a red marble is chosen and replaced, it's replaced. So I'm going to go like this, different color. Replaced. That doesn't really affect us at all. The first event and the second event, like, it's not affected. What's the probability of choosing another red marble? Just make an arrow here, just saying nothing changes for second event. Therefore, this would be independent. So it's basically business as usual, like nothing really changes there. Nothing really changes. So we go probability of red would simply be 10, and we have 3 to begin with, right? So it'd be 3 over 10, which is 0.3, which is 30%. So when it's not replaced, dependent. When it's replaced, independent. Can I do that here? I just want to make sure. I want to write under not replaced, dependent. Maybe I'll add a little bit more even, if you don't mind. A blue marble is chosen. This would be first event, and then drawing a red next. So this would be second event. Okay. So first event, second event. You have blue marble is chosen. That's the first event. And then drawing another blue marble, this would be your second event. First, second. This would be red marble chosen first. That's my first event. Another red would be your second event. By the way, down the road, I will have probably at least a third event yet happening. So someone draws a red one, then a blue one. What's the chances on the third one, somebody drawing a green, for example? So you just have to think a little bit what's happening, how do the previous events affect what's happening next, okay? I'm gonna let go of your hand for a bit, and you're gonna do this yourselves, knowing full well that the risk is 0. It's like -5, just like our temperature outside. You go over to page 50, try to read the scenario, and ultimately you got to come up with a probability. Try to first determine, is there replacement, is there no replacement? And try to follow that line. I'm gonna give you a little bit of work to do at home. Okay, so a green marble is drawn, not returned. That's key. So get rid of that green one. Another, and then you're drawing another green. So what's the probability of getting that? Well, you have only 9 left. Count how many are left. And there's only 1 green in the bag left. So that's 1 out of 9. That's it. You draw a blue marble first. So get rid of the blue. A green one next. Get rid of that green. They're both not replaced. Obviously, that's why we're removing them. What's the probability of drawing a red marble on the third draw? So obviously the total, we're down to 8. And how many reds are left? 3. Notice that the number of reds has not been affected by the previous events, and that's normal. Sometimes it does, sometimes it doesn't. Okay. Next, if a red marble is chosen first, okay, a green one, what's the probability of getting a red on the third draw? There are 8 marbles left, and there's only 2 red ones, correct? This is 1 over 4. So in this case, the previous event did affect my numerator as well, right? From the very beginning, we used to have 3, now we're only down to 2. Okay. If a green marble is chosen, they returned, sorry. You hopefully read that carefully, not like me. They are both returned. Nothing changes. It's almost like, why did you even tell me this, Mr. Dirksen? Like, why did you tell me what happened before? Because they returned it. It doesn't really matter. Green on the third draw, there are 2 greens out of 10, right? Notice that total remains unchanged, right? Total remains unchanged because of the returning part. It's almost like, as I just said, why did you tell me the previous story? Like, it doesn't matter at all, because your chances do not change regardless of what was done before. I want you to come with me. I want you to do the card one, and I put you another full deck of cards there so you don't have an excuse. I don't know deck of cards, Mr. Dirksen. There it is again. So 51 and 52. 51 to 53, I'd say. It's not that much, honestly. Get into the habit of doing a little bit of work outside of class. Just get into that habit. If you don't do it, you're going to pay for courses down the road, and you don't want to be failing or doing badly on a course. Sometimes they have prerequisites for what's happening after. Right? It's like, hey, in order to take this other course, you must have a minimum of this on the other course, right? So it means work. That's what it means. Right? Do some work. So I'm going to post those pages for sure. Probably more than just those pages, because I have them kind of like in a big chunk at a time. So if you want more practice, you go for it. You go for it. Thank you, guys.